Hello beta, good evening everyone. This is question number 7.4 of Devore chapter 7. Let us try to read the question. It says a confidence interval is desired for the true average stray load loss for a certain type of induction motor when the line current is held for 10 amps for a second of 1500 RPM. Assume that the stray load loss is normally distributed with sigma equal to 3. Compute a 95% confidence interval for mu when n is equal to 25 and mean is 58.3. Okay, so let's see this. So I need to go to the Z table first and I need to find for 95% level of confidence interval. So I'm just going to quickly go to my Z table. If I just go to my Z table, you will realize that this table is giving me this value. Look at the shaded region. Now, what has been asked is this 95%. So this is 0.95. And this is, if this is 95%, so I need to divide it by 2. So I realize that if I just look at this region, this will be 0.95 divided by 2, 0.4, and this is going to be 14.75, 0.475. So if I just look for the value 0.475, I realize that it comes here, which is approximately to 1.96. So my Z value corresponding to this is 1.96. It is 1.96. So what I am going to go ahead and do is, I have understood that my Z alpha by 2 is 1.96. And now I'm going to calculate my confidence interval, which is going to be X bar plus minus standard error into Z alpha by 2. My mean value is 58.3 plus minus. My standard error is sigma by root n. So sigma is given to me as 3. So 3 by root 25 and the Z value is 1.96. So I will go ahead and get 58.3 plus minus 3 by 5 into 1.96. And when you will be solving this, you will get 57.1, comma. So once you will subtract this value, once you will add this value, comma, 59.5. And this will be your confidence interval. Now, if we go to the next question, it says compute 95% confidence interval when n is equal to 100. So this is pretty simple. All that you have to do in the second question is just remove n being 25 and make it 200. So this will come out to be 10. And when you will add and subtract this value from 58.3, you will get the answer as 57.7, comma 58.9. Right? So that is going to be your second part. Read this third part, please. It says compute 99% confidence when n is 100 and the mean is 58.3. So we know without even looking at table that for 99% confidence, Z value is 2.58. Z value is 2.58. So what I will do is, instead of 1.96, I will replace this with 2.58. And once I replace this with 2.58, I am going to go ahead and I'm going to get the answer as 57.5, comma 59.1. And this will be my interval. Compute an 82% confidence interval. So just try to understand. If I say that this region I want to be 82%, that means 0.82. That means I want this half of the region to be 0.41. So I need to go to the table and I need to find out where is this 0.41. Okay, quickly let's go on to the table. Okay, use your good eyesight and find 0.41 for me. I think it is approximately this. 1.34 looks like a good option, 0.4099, so closest to 0.41. So I will use the value as 1.34, and what I will do is I will just replace my Z with 1.34 and 1.34. Right? So when you will be going ahead and solving this, you will go ahead and you will see that answer will be 57.9, 58.7. Right? Okay. It says, look at the fifth part. How large must be n if width of 99% for mu is to be 1, So it is saying, see, try to understand. See, when we write the confidence interval of mu, it is x bar minus plus standard error into the value of z. This part, this is called as width. This defines the width, how much you are adding or subtracting. So you're given that you want that this width should be 1. So standard error into z should be 1. So try to understand, standard error is sigma by root n, and you're given that it is 99% interval. So value is 2.58. So this is 1, and you're given that sigma that is given to you as 3. So 3 by root n into 2.58 is 1. So root n will be 3 into 2.58, right? 3 into 2.58. So your, oh, just one thing here, huh? See, try to understand this thing. Whenever we write the value of this z, right? This is z alpha by 2. Because we have already, we were finding this region, right? And this was z alpha by 2. And this is with a minus sign. So if I want to find the width, right, I need to find alpha first, right? This is alpha for alpha by 2. So I need to make sure that I multiply it with 2, right? So here I will also have a 2 right across. And if this does not make sense, so what you can do is just try to think that if my mean is 0, so when I suppose I subtract 4 from it and I add 4 to it, right? So I subtract 4 and I add 4 and I tell you this is the width. So what is the width? The width is not 4. The width is this entire 8 units. The gap between this and this is the width, right? So we are subtracting, so it is going below, and we are adding and it is going above. So the entire gap is going to be the width, right? So for width, we multiply with 2 also, right? So your n will be 3 into 2.58 into 2 whole square. So when you will square this, you will get approximately 239.62, which means 240, right? So your sample size must be 240. Sample size must be 240. Okay, thank you.